Hi everyone, today we are going to solve this problem. Rotate image. You're given an n cross n matrix representing an image. Rotate the image by 90 degrees. You have to rotate the image in place. That means you cannot use any other matrix. The space complexity needs to be big of n. Let's take one example. If let's say our matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9, we have to flip this by 90 degree to 1 2 3, 1 2 3, 4 5 6 7 8 9, 1 2 3 4 5 6 7 8 9, as we can see in this example as well. Okay, sure. And this is called rotation by 90 degrees. Now, if you would have worked on matrices, you would have heard of a concept, transpose. We are going to use this concept, transpose, in this question. Transpose of a matrix means just flip items kept at I comma j, where I represents the row position and j represents column position, to j comma I. That means if we took our initial matrix as an example, we'll look at what the transpose this matrix is. Here I comma j is 0 comma 0. We just keep 0 comma 0 as 0 comma 0 at this place. This one is 0 comma 1. Row, sorry, this row is 1 and column is 0, 1 comma 0. So we have to keep this at 0 comma 1. That is, row changes to column, column changes to row. So that will come here, and this one is going to go here. Similarly, this one has the current row of 0 and column of 1. We have to keep this at 1 comma 0. Row is 1, column is 0. This one stays as it is because row and column are same, and this one has a row of 1 and column of 2. We have to keep this at row of 2 and column of 1. Row of 2, column of 1, we have to keep 6 here. So this is 1 2 3 4 5 6 and 7 8 9. So this is the transpose of initial matrix. Now if you look at the transpose and rotation by 90 degrees, do you see anything? You'll see that they are pretty much similar. It is just that if you grab every row, we are just reversing it, right? This row is 741, this is 147, this is 852, this is 258, and this is just 963, 369, right? So in order to solve this problem of 90-degree rotation, we have to take two steps. First is finding out the transpose of the matrix, and then reverse all the rows, and that is all. Let's solve this problem. Let's create a function to transpose this matrix. Transposing is not that difficult. We iterate through all, you know what, all the rows, and then all the columns. Now there's something interesting going on in here. You have to understand that in order to, let me clean few things. In order to find the transpose, in order to do I, j, changing to ji, we have something to consider. We cannot just grab any I comma j and flip it or swap it to j comma I, because if let's say we are just scanning through the complete array, we go to 1, 1 stays as it is, we go to 2, we have to flip 2 with 4, right? So let's say we flipped 2 with 4, new value at this index is 4, and new value at this one is 2. Then we got move to 3, we flip 3 with 7, the value is 7, the value is 3. If we continue the iteration, we are again going to grab 2, we are going to again flip 4 with 2, and we stay at the same position. We basically we swap a and b, and then we swap a and b again, so it gets back to the initial position. So we have to make sure that if we have touched any index, we have processed any index, we do not touch that index again. In order to do this, the things, it is not very difficult. What we'll do is, we, let's say, will divide this matrix into two areas, right? First is green area and second is red area. We'll say we are just going to iterate through one of the areas. It is up to us, we can pick red or green. Let's say for our case, we are going to pick the green area, and then we iterate through this first index, second index, 3 indexes. Then we keep on going ahead and we keep on finding the element that we have to swap with. In this way, we'll keep on swapping them, and because we are not going to touch this half array, after complete iteration we'll find out that this half is already swapped, is already processed. So we basically have to scan through just half of the index. It is up to us which one we would like to pick, and that is why I'm saying here we iterate through all the rows and we just go through the columns in such a way that j at max gets to I. So we are basically iterating through this part, right? And then we do normal swapping stuff. We keep I and j, we replace I and j with j and I, and at the end we do j and I with temp, and we are done for the day. We are done. Our matrix has been transposed. What's next? We've completed our first step, that is transposing the matrix, converting all the ij's to ji's, and then we are going to reverse it. Reversing the matrix is not difficult either. Okay, so we iterate through all the rows, right? For every row we grab two indexes, we keep on swapping them till we reach to the half point. So we pick left as 0, we keep right at this right hand, we do while left is less than right, we grab the matrix at left, we keep right at this position, and we keep temp at right. We keep on doing left plus plus and right minus minus at the same time. Okay, sure. We are done for the day. We are done with reverse as well. And then we do transpose this matrix and then reverse this matrix, please. Let's scan through the functions, make sure we have not made any major problems. We have not created any major problems. Left, right. Okay, transpose I, j, when I is equal to j, it doesn't matter even if it swaps. Okay, let's run this. Let's submit this. And it has been submitted. Fine. Runtime is good, memory is good as well. So this is the solution. Rotate any matrix by 90 degrees is just transpose and then reverse. Thank you.